So our topic in this video will be about kirchoffs laws. So we have types of laws that we are using in electrical circuit. We have our KCL and KVL. For kirchoffs current law, yung tinatawag nating KCL, okay? Applicable to for parallel circuits. Not only parallel actually, interconnection of circuits wherein meron tayong iba't ibang klase ng nodes wherein according to our Kirchhoff's laws, ito yung the algebraic sum of currents entering a node or a closed boundary is 0. So meaning kasi nito, yung algebraic sum niya is the sum the currents na pumapasok at lumalabas sa node. Okay? So currents entering a node may be regarded as positive. Okay? Currents entering a node may be regarded as positive, while currents leaving the node may be taken as negative or vice versa. Depende sa'yo. Okay? Depende kung ano yung trip mo. Kung yung negative naman yung pagpasok, okay lang naman, tapos yung palabas is positive. As long as the sum of them or the summation of this current is equal to 0. So n is the number of branches connected to the node and is the nth current entering or leaving the node. So let's say yung node natin has 5 interconnection between it. Let's say we have our current I1, current I2, I3, I4, I5. So if we would want to solve for either or any of I1, I2, I3, I4, and I5, of course, lima yung current na yan. It is entering or going out the node. Let's say this will be our node A. So pag gagawa tayo ng equation para dito, or let's say an equation entering and going out, or if you would want to find out any current in the equation which is represented by the currents entering and going out our node A, so gagawin lang natin ganito. So first identify natin kung yung current natin is papasok or palabas sa node. So as you can see, there are 5 branches that are going there are 5 branches that are interconnected in our node A. Okay? So let's identify that our I1, so as you can see, yung arrow natin paloob, pasok, means that is entering. Yung I5 natin palabas is leaving. I4 entering. I3 leaving. Entering, I should say. I2 leaving. Common question is, lagi bang given yung direction ng current? Actually, hindi. In any circuit calculation, pag hindi given yung mga direction ng current nyo, you can assign. Okay? Kasi pag yung assumption naman baliktad, magti-negative naman siya. Okay? The negative sign will just an indication is that nabaliktarin mo yung current direction mo. Okay? So as you can see, number 1 is entering, so that's why it is positive. Okay? Yun yung sign convention natin. I2 is leaving, that's why this is negative. I3 is entering, that's why it is positive. I4 is entering, that's why it is positive. And of course, yung ating I5 is leaving, so that's why it is negative, equals 0. But probably, pag gusto mo namang sabihin na yung entering mo is negative, so that's why pwede natin sabihin na I1 is negative, negative I1, tapos yung leaving mo is positive, so positive I2, negative I3, negative I4, and then positive I5 equals 0. Papansin mo, pag transpose mo lang naman yan ulit dito sa kabilang equation, we will have the same equation as this one. So, parehas lang sila. Okay? So, nasa sa'yo lang yung orientation mo kung paano mo atakin yung problem. Siyempre, dapat, pag matake ka ng problem, like this current, KCL and KVL, dapat kung ano yung pinakagamay mong sign convention, yun yung gamitin mo. Okay? So, yan. But para sa akin kasi, nasanay ako na entering the node is positive and going out the node is negative. Okay? So, let's have this example. Okay, let's find out for the value of the current I1. Okay? And we have our I2, our I3. Okay. So, first things first, bago natin yung isolve, of course, i-identify natin yung mga nodes natin. Pero naman talaga, di ba? Identify natin kung ano yung node. So, ano ba yung node? It is the interconnection of the different branch circuit. Kasali ba yung connection ng node sa series? Diba balik tayo sa definition ng series, diba? A series connection has the same current. So, therefore, whatever the current of the node connected to the other nodes, so yun na rin yung current niya. Okay, so therefore, hindi na natin i-consider yung nodes in series connections. Okay? So first, identify natin yung mga nodes natin. So let's say, we have our node A, okay, node B, node C. Okay? So these are the particular nodes that are highlighted in our equation. Okay? Or in our circuit. So that's why baka dito natin kukunin yung current at node A, current of I1 at node A, current at I2 at node B, and current at I3 at node C. But particularly, there are other nodes that can be used in our example. Let's say we have our node D. Let's say this will be our node D. Meron din tayong another node dito, which may be our node E. Then another node dito at node F. Okay? So, let's apply our KCL or our Kirchhoff's current law. Let's say, let's have our KCL. So, let's find for I1, I2, and I3. Okay. So, ngayon, let's find them using, syempre, our KCL. Okay, pag mag-KCL tayo at node D, okay? So, KCL at node D. Itong sa node na to. Ito is prove natin that the summation of current entering and going out the node is 0. So, pag nag-KCL tayo at node D, papansin mo na meron tayong 10 ampere leaving the node. So, negative 10. 8 ampere entering the node. And 2 ampere entering the node is equal to 0. Papansin mo that we have 8 plus 2 is 10, negative 10, plus positive 10 equals 0 equals 0. So, this is the proof that the summation of current entering and leaving a node is always 0. Okay. So, let's find for I1 muna. Finding for I1. So, paano ba yung I1 natin? Ito yung I1 natin, di ba? So, mayroon tayong dalawang solution na pwede. We can have our KCL at node E and KCL at node A, or KCL at node A. So let us consider KCL. KCL at node A. So considering our node A, which is ito, the currents that are entering the node are yung ating I1. So positive I1. So positive I1. And then the currents that are leaving the node are our 2 ampere and our 12 ampere. So we have negative 2 less 12 equals 0. So therefore, I1 is equal to negative 2 less 12 is negative 14. Pag transpose natin, magiging positive 14 ampere. Okay? Next, consider natin to at node E. So at node E, so ano ba yung node E natin? Ito yun, di ba? So, take note that I1 is leaving our node E. So, we have negative I1. Currents entering our node E, yung ating 10 ampere, di ba? So, plus 10. And then our 4 ampere. So, plus 4 equals 0. So, pag transpose natin yung I1 natin, it will give us 14 ampere. So, whatever node that you would take, as long as the current that you are solving is involved, no? So, pwede natin gamitin kahit anong node dun. Yun at yun pa rin yung makukuha natin current. So, let's solve for the value of our anong pwede. Pinakamaganda is yung I3 natin and I2. So, ito yung diskarte. If we would take KCL at node F, so KCL at node F, so find I2 and I3. Find I2 muna tayo. So, if we would take KCL at node F, so ito yung F natin. So, ano yung mga currents na pumapasok dyan? Meron tayong I2, meron tayong I3. Okay? So, you can see that we have I2 entering, no? And I3 entering. So, I2 plus I3. And then we can see that 8 ampere is leaving. So, minus 8 equals 0. So, we have I2 plus I3 is equal to 8. You can see that you cannot directly solve for our I2 and our I3. Okay? So, let's say this will be our equation 1. But, in this case kasi, na-given naman na yung mga current, you can see that we can solve any of the two, which is our I2 or I3, or I2 or I3, no? Kasi, if I would take KCL at node B for solving for my I2, so KCL at node B, KCL at node B, no? So, ano yung node B ko? Ito yon. So, mapapansin mo that our currents going out is yung aking 2 ampere. So, I2, so negative siya. Negative I2. Current going in is yung aking 12 ampere. So, plus 12 ampere. And then, current going out na naman yung aking 14 ampere. So, negative 14 equals 0. So, pag tinaspose ko yung I2 ko, I will have 12 less 14 is negative 2. Okay? So, yan. That is my current in my I2. Okay? Next. For my I3. So, solving for my I3. So, finding for I3. So, dito natin siya ilagay. finding for I3. So, paano ba natin i-solve yung I3? So, ito yung I3 natin. Napapansin mo, sa node C tayo, di ba? Ito yung pinakamaganda kasi may 14 ampere na papasok, may 4 ampere na palabas, at yung I3 natin palabas. Okay, palabas yan. So, we have negative I3 because it is going out the node plus yung ating 14 ampere papasok minus 4 ampere palabas. So, plus 14 less 4. Finding for I3 KCL at node C. Okay, so yan. So, we have 14 less 4, okay, is equal to my negative I3. So, therefore, my I3 is equal to positive 10 ampere. Okay, so this is my I3. So, i-recheck natin. Okay, so if I would substitute my 10 ampere here and my negative 2 ampere here, I will have negative 2 plus positive 10, it is equal to 8. So, for 8 is equal to 8. So, pag transpose ko yan, 8 less 8 equals 0. So, 0 equals 0. Which will go back to our KCL or currents Kirchhoffs law, wherein it states that the currents entering and leaving the node is always equal to 0. Okay? Yan ang ating KCL. So, let's solve for another example. So, ito. Let's have our example number 2. So, dito, let's find for our I2, I3, I1. Find for I1, I2, and our I3 and I4. First things first, pag mga ganito, ang lagi nating uunahin talaga is yung pag-identify ng node. Okay? So, wag kayo magkakalculate hanggang hindi nyo alam yung mga nodes nyo. This is my node A. This is my node B. This is my node C. And this is my node D. So, ano ba ang kahalagaan ng pag-identify ng node? Number 1 is to avoid confusion on the direction of your current, lalo na pag yung mga node na yan magkakatabi. Okay? And number 2 is that to avoid confusion in getting the equation of any currents that would be solved. Okay? So, dito, para mahanap na rin natin kung ano yung pinakamadaling gawin. Okay? First, pag nag-KCL ako sa node A, so KCL at node A, ano ba yung diskarte ko dito? Is to find for I1 or I2, di ba? Kasi yan naman yung mga currents that are entering the node or going out the node. So, mapapansin mo, yung 2 ampere ko is entering the node. My I2 and my I1 is entering the node, I should say. So, positive yan, tama? So, I1 plus I2. And then, my 2 ampere is going out the node. So, negative 2 is equal to 0. So, therefore, I may say that I1 plus I2 is equal to 2. So, number 1 tip, pag mga ganitong hindi kayo yung naglagay ng sarili nyong current direction, tapos may manalagay na current direction, wag nyong papalitan yung direction hanggang sa matapos yung calculation. Okay? Pag may negative, okay lang. As long as pag nag-summation ka sa isang node, let's say node A is always equal to 0. Pero pag nakakuha ka ng unknown node, tapos let's say dalawa yung unknown node dito, let's say I1 and I2, tapos pag pinag-add mo silang dalawa, and then i-less mo sa yung 2, hindi equal sa 0, ibig sabihin, may mali sa current diagram mo, or may biniligtad kang current direction sa middle ng calculation, or nagkamali ka sa pag-compute. Yun lang yun. Okay? So, our node A, so nag-KCL tayo sa node A natin. So, you have I1 plus I2 is equal to 2. So, next, mag-KCL tayo sa node B. So, KCL at node B, mapapansin mo, yung I2 natin, it is leaving the node. So, B, so we have negative I2. And then we have 3 ampere also leaving the node. 3 ampere. Huwag ko na muna ilagay yung ampere, no? So, 3 also leaving the node. And then yung 7 also leaving the node. Equals 0. So, I2 is equal to negative 7 less negative 3 is equal to negative 10. Next, KCL tayo dito sa node C. So, KCL at node C. So, as you can see, 7 ampere is entering the node. Okay? And then yung I3 natin is leaving the node. And then yung I4 natin is entering the node. Equals 0. Okay? So, actually, this is I3. Hindi yan 3. So, I3. Okay? So, equals 0. So, therefore, I will have I4 less I3 is equal to negative 7. This is another equation. Next, let's have our D. So, KCL at node D. Okay? So, current entering the node D is our positive 2 ampere. And then leaving the node D is negative 4 ampere. And then of course, meron din nagli-leave which is equal to I4 equals 0. So, from here, pwede yung sabihin that my I4 is equal to 2 less 4 is equal to negative 2. Okay? 2 less 4 is equal to negative 2. Next, meron tayong I4. Meron na rin tayong I2. Pwede natin gawin is substitute natin itong mga to dito. We have I1 less 10 is equal to 2. So, therefore, I1 is equal to 2 plus 10 equals 12 ampere. Okay? So, correct yan. Next, yung I4 natin, meron na dito. So, therefore, pwede natin substitute to dito. We have negative 2 less I3 is equal to negative 7. So, therefore, negative I3 is equal to negative 7 plus 2. Okay? Which will give me 5, no? So, therefore, I3 is equal to negative 5. So, ngayon, check natin yan. So, pag may I3 is equal to negative 5, tapos, yung I4 ko is equal to negative 2. Okay? So, if we would get the sum of currents entering the node, so we have negative 2 and our negative 3. So, check natin, no? Checking na to. And then, yung I3 ko is negative 5. So, we have I3 is equal to negative 5. So, negative 2 less negative 5, no? So, you have negative 2 plus 5 is equal to negative 7. So, 3 is equal to negative 7, which will not give me the correct answer, which is 0. So, ngayon, baka nagkamali ako dito. Okay. So, try natin tignan kung ano yung mali. Okay. So, counter-checking muna tayo. Yung I1 ko is equal to dapat positive 2. So, 12 ampere. Pag sinubstitute ko yung 2 ko, o yung I1 ko, 12 ampere. Sinubstitute ko yung I2 ko, negative 10 equals 2. So, therefore, 2 is equal to 2. So, transpose ko yung 2. So, 0 is equal to 0. So, therefore, this is correct. X. Dito tayo sa node C. Okay, dito tayo nagkakatalo. So, may current 7 is entering the node. 7 less my I3 which is leaving the node plus 4 equals 0. So, from here, I4 is equal to negative 3 is equal to negative 7. So, from here, yung I4 ko is equal to negative 2. Okay. So I4 ko is equal to negative 2. So from my, paano ko ba nakuha yung negative 2 kanina? Dito. So you have current entering which is positive 2, current leaving which is equal to negative 4, and current leaving which is equal to I4. So which will give me I4 is equal to 2 less 4, which will give me negative 2. So dito no, dito lang naman na ako nagtalo eh. So I3 going out the node, negative 3, I4 going in the node, 7. So ayan. So pag yung I3 ko, no? So I3 transpose ko siya. So I3 is equal to 7 plus I4, which will give me 7 minus 2, which is equal to positive 5. Okay. Alam ko na kung bakit. So this is negative I3, negative 7. This must be negative 5. Negative 1, negative 1 divided by negative 1 must be positive 5. So my I3 should be equal to positive 5. So pag nag-positive 5 yung I3 ko, so positive 5 yan. So therefore, I will have negative 2 less 5, di ba? So we have a value equal to negative 7, which is equal to negative 7. So pag tinranspose ko yung isa, negative 7 plus 7 equals 0. So that would be our answer. I1 is equal to 12 ampere, I2 is equal to negative 10, I3 is equal to positive 5 ampere, and I4 will be equal to negative 2 ampere. So pag nagkamali ka, or para ma-check mo na mabuti, mag-summation at mag-summation ko ulit sa mga node mo, A, B, C, D. Pag may hindi mag-0, ibig sabihin, may isa kang mali. So yung nagawa ko kanina, yung implication nun is that parang binaliktad ko yung current. Imbis sana na pag ganito, na negative 5, ang ginawa ko, pinapasok ko, di ba? Tapos hindi pa ako nagbaliktad. Okay? So that's why my answer here is equal to positive 5 going down. Okay? So, yun yung sinasabi ko kanina, pag bigla mong binaliktad yung current na hindi mo pinalitan yung magnitude. Okay? So, ganun yun. Okay? Yun yung magiging parang mali pag sa KCL method. So, take note, as I have said, kung ano na yung pre-assumed direction of current mo para hindi ka magkamali later on is that yun at yun na yung kakamitin mong direction until matapos yung calculation mo. Okay? So, para magkaroon tayo ng uniform answers, ako na yung magbibigay ng directions ng current natin. So, this is our KCL method.